Hey everyone, and welcome back to the SaaS Developer channel, where we share cool ideas around building software as a service. In recent survey, we found out that a lot of people in the community are very much into infrastructure and very much into data infrastructure. So I invited Oz Katz from LakeFS, the open source community, and Treeverse, the company, which he co-founded and the CTO of. And they're doing one of the things that are probably the most, out there ideas that have not ever heard before in this field of data infrastructure. So I have a lot of questions to ask him. I was so happy to have you here.
Thank you, Gwen. Really happy to be on your show. I've been a viewer of it, probably since the beginning. I loved your Excalidraw one, by the way. We use it all the time at Treeverse, so thank you for that. I learned a few things.
Do you guys use Excalidraw?
Yeah, I use it heavily. Sometimes not everyone's a big fan as me, but I use it all the time.
Yeah, I found it the most useful when we talk to customers or prospects, and we kind of like, okay, let us try to draw the architecture, describe it, and I'll draw it. Does that look right? Do I have mistakes here? It makes it easy to get on the same page, while most people are still remote. I haven't flew to visit people in ages.
Yeah, likewise. Just being able to like draw two squares and not worry about them like aligning perfectly, like pixel to pixel, just removing all that burden.
Exactly, and it just feels informal and like it feels like a whiteboard, which is exactly what we wanted all along.
Yeah.
Yes. So let's start with maybe the most impressive thing that I've seen you guys publish in the last year. You published your view of the data engineering space. It was the State of Data Engineering 2022. And you basically kind of explained the big parts of data engineering. Super useful. What would you highlight as the more interesting changes out of this ever-moving configuration of boxes?
Yeah, so actually the State of Data Engineering, the series of blog posts, because we've been publishing this every year for 2 years now, but that's already a series, right? So the credit there is due to Einat, my co-founder. It's based on her like market research that we do for LakeFS, right? So we try to be as agnostic as possible. It's kind of like part of our philosophy. We want to fit in with the rest of the ecosystem. So it's really important for us to kind of map it out. And it's really an interesting experiment to do like year after year because things in this space just change so often. I mean, like you blink and suddenly everything's different. Right? Snowflake used to be the biggest player. Now Databricks is, and who knows what happens next year. And it's an exciting time to be a data engineer.
Your post resonated so much because we're all struggling to keep up and suddenly someone went and did the research.
Yeah. And I mean, by the time we finish publishing the post, it's almost obsolete at that point. I mean, just because it's moving so fast.
Exactly.
So I think for me, like maybe the kind of, I don't know if the most surprising thing, but probably the biggest thing to take note of is kind of how things went from like an explosion of tools to now kind of starting to converge a little bit. So we see it mostly, I think, around like machine learning, MLOps tools. It used to be like, do one thing and do it well. I come from systems engineering, so like Linux, and all the Unix philosophy really works for me. So most of them started as like just doing orchestration, just doing metrics, just doing logging, just doing one specific thing to now like big end-to-end solutions. Like we see like Databricks and stuff.
We're rebundling. We are the rebundling phase of the unbundling cycle.
Yeah. We're on that wave. Maybe next year it's going to disaggregate again and be a bunch of small tools once again. I don't know, but it's really interesting, like the trends and how they work.
Do you find that the industry is maturing? Because when all the tools are very new, they can only do one thing. How much can you do with a very new tool?
Yeah.
As things mature, they start doing more and more, and this kind of leads to those conversions, maybe.
I think, maturity is one aspect, but I might even say evolution, where maybe the less valuable tools get kind of bundled up as a feature by other tools.
Yeah, this makes
some of them. Yeah, I mean, just the cost of integrating different solutions. If you have something that's super tiny but requires a lot of effort to put in place,
it would be prohibitive to pick it up. I agree. And it's interesting because the stress is really more on the kind of consumer side, right? As a developer, you have to pick a set of tools. On one hand, like I don't really want to be running. I am a 6-person startup. I don't want to run 50 tools. It makes no sense for me. On the other hand, we do want to use the right tool for the job. So
exactly.
you can pull together a bunch of one tools into something that actually works together, and I don't have the mental overhead. It's kind of the best of all worlds.
Yeah, and I think maybe like the second trend we're seeing is, and Einat calls this data-centric AI, or like
Data-centric AI. Isn't AI always data-centric?
You would think, right? But in many cases, like you would have typically like small learning sets, but then a lot of effort put into the model.
Oh, so instead of trying to have extremely smart models on the little data you have, you actually have simpler models on a lot of data?
Yeah, in many cases. Or sometimes it's even complex models and interconnected models, but the input data is just very big and very interconnected as well, right? So
I see. Oh, interesting.
yeah,
And
we
this is
see a lot of
something that
companies.
Google predicted ages ago, right? Like that
Yeah,
data eat models for breakfast.
exactly that. Yeah. So we're kind of seeing that, and many tools also popping up in this space. And like data quality there is really a key aspect, right? And this is maybe true for every type of data, not just stuff for AI. But the old saying of like garbage in, garbage out still holds very true.
Yeah.
If you base your models on something you can't really trust, then you end up with poorly behaving models.
Yeah. So so this is more like, okay, you're seeing multiple small tools getting bundled into one. Are there new categories that we should all keep an eye on?
So that's a good question. New is a relative term, right? In many cases, it's like taking something old and holding it a bit differently, and now it's something new, right?
Yes.
So in a way, we see, like at least from our biased perspective, we see a lot of similarities now between data engineering as a practice and software engineering, right? So
yes,
a lot more tools to talk about.
The shift left trend.
Exactly.
This has been the biggest. You are the second person from this space to be pointing it out on this podcast. So definitely this is it's a thing, guys. If you're not shifting your data engineering left and taking software engineering practices, you're clearly behind the curve.
Exactly. And I mean, like we see all this talk nowadays about like data mesh and data as a product.
Yes.
And if data is a product, that means that you're holding a service in production, whether you like it or not, right?
Yeah.
It's not a web service. It's typically like an S3 directory, but all the same rules apply. So
while preparing for this podcast, I kind of like, okay, let me revisit the entire data world. It's probably changed since I last took a look. And I noticed two trends that I was not aware of earlier that I was like, oh, maybe we should, this is kind of, maybe it's early, but worth taking a look. Actually, maybe three. So the first one was the embedded databases are having their field day. It used to be that you can obviously embed a key value store. It's a cache, that's easy. And like RocksDB was the same. Very few people actually outside the mobile world really try to embed a relational database. Now they have those embedded OLAPs. So DuckDB and 5 different DuckDB variants out there. It's kind of insane. So it's on my list. Catch up what happened there. I did not notice DuckDB until this second. And the other one that is slightly related, really those hybrid databases that are half cache, half database, and they have all those really smart algorithms to sync it up. And then the stuff being done on top of Postgres. Just seems like I'm seeing more and more databases that are actually Postgres. That's not a new trend. Tisa ages ago was on top of Postgres.
Yeah, but it's definitely something that's picking up, and,
Yes.
and we see more and more of these.
Yeah, it was always a good idea, and apparently it just got better.
Yeah, and I think for some reason, like data engineers especially, like they have some affinity towards Postgres. That's at least what we're seeing.
Yes.
Okay,
Yeah.
it's a good like OLTP solution to have in place around surrounded by OLAP stuff.
Yeah.
Sometimes you just need to pull a value from somewhere.
Since you have this great view of what data engineers do, are there any other tools that they just have this enduring affinity outside of Postgres?
So it's interesting because like I originally come from systems engineering, right? So
Yeah.
there are kind of tools that I always kind of gravitate towards, right? I'd always have a terminal open. Even now when I'm not writing code, I have a terminal, and sometimes I'll just like command tab, do an ls for no reason, just I can't explain it. It seems that nowadays, so for data engineers, that ls would be kind of a notebook. They have Jupyter running.
Ooh,
Use
you're
it
right.
Python for everything.
Yes.
They like living there. I can see why, by the way. It's a super useful tool.
Yeah.
But for us, we already kind of figured this is our path of least resistance, right? If we manage to work
They
well
just
with
have a notebook, run something in the notebook, see results, iterate. Like I have a question, do it in a notebook.
Yeah, and it's super easy to
Interesting.
share. It's super easy to connect to like external utilities, libraries, compute engines. It's like
Yeah.
the shell or the REPL reinvented kind of.
Yeah. And like another thing about it, yeah, Databricks obviously built it in ages ago. Snowflake haven't yet. Like,
True.
they have to catch up.
Yeah. By the way, an interesting company in that field is Hex, which I love.
Hex. Okay.
Yeah.
It's
about
small banners so people will see that apparently Hex is the thing, and they do notebooks.
It's kind of a reincarnation of the notebook. So it's a notebook that you can like plug variables into, kind of like a template, and then get a dashboard out of that. So if you do like visualizations within the notebook and markdown within the notebook, you can just change a value and you change it throughout the notebook and renders kind of like an application. So
nice. Yeah. This is not something notebooks just always did.
Not that easily. I mean, it's like
you can see
really baked into the product.
Amazing. So yeah, definitely, guys, take a look. So if we go back to on the shift lefting and data engineering becoming software engineering, very welcome friend. Obviously, the change that you've been pushing and talking about and advocating for is really the concept of Git for data. Like you would not do software engineering with no Git. How can you possibly do data engineering with no Git? So can you just walk us through, like, what does it even mean? Like if someone says I'm doing Git for data, what should we expect it to do?
Sure. So the idea at its core is very simple. I mean, imagine you could take the capabilities that Git provides, branches, commits, tags, being able to roll back, look at like previous versions. But instead of managing the code itself, I mean, that's the artifact for Git, you would manage the data. So imagine like all these capabilities, but for like your S3 bucket, blob store, or whatever it is, wherever it is that you store your actual data on, you would be able to get those capabilities.
Interesting. And you're also thinking, because you mentioned all those things that are not just part of Git, but really tied to the release lifecycle, right? Like you mentioned tags, which is obviously part of releases. You mentioned rollbacks, clearly something that you would want as part of your CI/CD. Sure. So if I need a Git for data solutions, I need those Git-like capabilities, branch, merge, promote, tag, and then also rollbacks, and it absolutely has to tie into my CI/CD of choice one way or another, kind of thing.
That's actually kind of the most important part, I would say. So like branching, merging, committing, it's not the goal, right? I, as an engineer, I don't want to commit stuff. I don't care about that. Yeah. Git is a means to an end. I want to have a very structured way of taking software from ideation all the way to production, to the user. That's what I want. I want quality checks along the way. I might want a review process along the way, promoting it through different environments like staging and dev and acceptance and whatever it is that the company is doing. I want to be able to structure that. Git allows me to do that. Git for data allows you to do it for, instead of like deploying a service to production, you want to deploy data to production. And you want those same guarantees and those same capabilities.
Yeah. So one of the things that I've been kind of trying to wrap my head around, because I'm now much more in the software engineering world than in the data engineering world. So the closest thing to what you described that I have is migrations. So I have Flyway, it lives in my Git. When I deploy, it does those things, it works with all my environments, etc. So as a data engineer, obviously Flyway is not enough, otherwise you wouldn't have Git for data. Can you talk me through scenarios that, hey, data engineer needs to do something and Flyway is not enough?
Sure. So let's take a naive example. Data engineers, their lives are based around pipelines, right?
Yes.
It's a big part of the job, right? You either have streams going into the object store and then pipelines, or you just directly have pipelines. No avoiding them. The thing about those is that, in essence, they're kind of like deploying to production directly, right? You can write unit tests for the pipeline itself, but what about the data that it modifies, right? Does the end result looks the way I want it to look? Right. So what typically happens
you're saying that some of these data sources have low quality control, so you need the quality controls in the data pipeline itself, which is almost the equivalent of a CI/CD pipeline for data engineering.
Exactly.
Interesting. Yeah.
If you talk about analytics, right? So a simple example would be I'm getting a lot of raw events from some client, and I want to aggregate them to hourly records, right? How many events I got per hour, per category, country, whatever metric I care about.
Yeah.
What happens if I want to change that logic, right? Or what happens if the SDK is now reporting something else?
Yeah, that's exactly what I was thinking. Because in my world, I'm the source of data. Clearly, I trust myself. The data is perfect. If you put it in your pipeline, the only way it will break is if your pipeline is broken, and please have unit test for that.
Yeah.
But if I know that there's a huge world in which you get data from public sources. We talk to people who get a lot of data from Twitter, from Facebook. They probably have a lot of their own notions of how stable the SDK should be. I heard that even if you get data from financial markets, there's actually serious churn on those SDKs. Payment processing SDKs tend to break with no reason. So yeah, that's amazing.
Yeah, and that's maybe one of the biggest changes from code, right? Because when you look at your code base, you have a lot more control over your end result than you do with data. But with data, you're almost by definition depend on someone else, right? Yes. Unless you take everything from the client all the way up to the analyst consuming the data, it probably involves at least one, typically a lot more than that, data sources that someone else provides you with.
Yeah.
So how can you give guarantees to your consumers?
So your thought is that obviously I need to use the Git for data when I add a new data source and to make sure it goes through this pipeline. And also maybe on a regular basis, how often do people normally branch their data?
So we designed LakeFS on purpose to make branching the cheapest operation possible. Right? Branching a huge data lake, petabytes of data, is milliseconds. It's just creating another pointer to an existing snapshot.
Yeah, that makes sense.
It's based on copy and write. That allows you to do a lot of pretty clever things, right? So imagine you have your daily pipeline, your hourly pipeline in Airflow or something like that. You started off by creating your own branch. Kind of think of it kind of like a transaction in that case. Run whatever transformation you want on that branch. Before releasing it at the end, you would do your data quality checks. You would validate that the data looks the way you wanted it to look, right? Not just as a unit test, but as kind of a system test, right? You're testing on actual live systems here.
Yeah.
And if that looks the way you want it to look, you would then commit and atomically merge all the results into your main branch, right? So if you have a data consumer, either they see data that has been validated, is complete, is not transient, is not partial, or they don't see data at all, but they never see something that failed midway or something that wasn't tested properly. And they can even look at like the code that does the testing and know exactly which guarantees they're getting.
If I have daily batches, I have all those controllers and checkpoints. Got it. But I looked at LakeFS yesterday doing my homework, and I saw a gigantic list of integrations that completely blew my mind. And I'm pretty sure I recall that some of them were very streamy. I saw Kafka there. I think I saw Materialize DB there. I may have been other things that are streamy. So I no longer have any batches. How am I supposed to do branching if I don't have batches?
That's a good question. I mean, how do you commit something that doesn't begin and end, right?
Yeah.
So what we see is it's not even a pattern that we made up. It's just something we observe our users doing, which is really interesting. So what they typically do is they create a branching strategy for this, where you have like what they call a dirty branch, which is just
so
like the most up-to-date data. Yeah, and like Kafka Connect would write directly into that dirty branch. And then it would have a process in place to take like the last 5 minutes, 10 minutes, 1 minute, whatever interval they're comfortable with, applying checks at that point in time, committing and merging that into a clean branch, let's say. So the consumer now gets a choice. I can either look at the most up-to-date but possibly bad data, or I can look at data that might be a minute, 5 minutes, 10 minutes behind, but is validated and I can trust it. Right? I get that trade-off. I can decide for myself which of those I want.
Yeah. I love that because I now recall recommending it myself in a slightly older world where we did Hadoop, and and it also even before that in data warehouses, right? You have ELT. You first dump all the data, then you do the pipeline. So
exactly. Which is kind of by definition garbage in, garbage out, right?
I mean, that's why you have the quality process and refinement process in between to make sure that it's garbage in, high quality data out. It's kind of amazing how in engineering we do this type of magic. Like you get garbage, you can actually take out good information out of a lot of garbage. If you have sufficient garbage, you may be able to find good things in there.
Yeah. I think in many cases, this is like the practice of good data engineering, right? You get so much noise out there, being able to separate the signal out of that's data engineering.
Exactly that. And it also applies in almost everywhere in computer engineering, right? Like we managed to build TCP on top of unreliable networks. We managed to build reliable storage on top of disks that in reality fail quite often, distressingly often, I would say.
Yeah.
So I think that's kind of like the trend of good engineering in general is to inject reliability into stuff that otherwise wouldn't.
Yeah, there's this blog post, I think, where like I don't remember where I saw it, but like myths about distributed systems.
Oh, yes.
Like one of the first one is that the network is reliable, which it never is, right? Yeah. You build for failure. You build for a very messy world. Yeah. And you want to build something that's reliable on top of that mess.
Yeah. Do you have stories that are kind of like, oh my God, out there? Like, either people were doing crazy stuff with LakeFS, people doing massive successes, like, if only we had LakeFS, we wouldn't be in this horrible postmortems that we're now stuck in.
I have a few.
It's always the good
stuff. So I'll start with my own personal, very embarrassing story.
Okay.
Which is kind of like what led us to build LakeFS, I think, in many ways. So prior to Treeverse, Einat and I, we were both working for SimilarWeb, which is an analytics company, with a pretty massive data lake in place, right? Multiple petabytes on S3, doing like all the best practices, working with the solution architects at AWS to ensure we're like doing everything properly, right? And still, this is not like a simple architecture. It's not an easy system to kind of introduce modifications into. And one of the most like notorious batch jobs that we had this really like naive, innocent name. It was called retention. Just by that word, you're probably like cringing, right?
Anything that's called retention means I'm deleting stuff.
Exactly.
By the way, in Kafka, it's the reverse. The thing that's called deletion actually does not delete stuff.
Yeah. This is also partially true for LakeFS. We can touch that later. So we wanted to add a change to retention, and there was like pretty complex logic of what actually is allowed to be deleted, right? Because you have all kinds of like dependencies between stuff, and I can't delete this data if that experiment depends on it, stuff like that.
I am already like, if it was a
seeing your
horror film,
face.
I'm kind of like, okay, please tell me when this scene is over.
So someone whose name I'm not going to mention, but he's on that call, and it's not you, wanted to introduce two changes. One was to fix kind of an edge case where stuff that was supposed to be deleted was not deleted. And the other one, just for engineering's sake, for no good reason whatsoever, to improve the performance of retention. So yeah, change some of the logic of how things actually get deleted. AWS S3, they have like a batch API where you can ask it to delete stuff. So introduce that. And I'm happy to say that at least a part of that change worked properly. It was much faster.
It deleted everything very efficiently.
So not everything, just one small petabyte of data, which was production data, the most important production data, pretty much.
Now I understand exactly why you founded your current company.
Yeah.
Like maybe, yeah.
And like the most annoying part is that we did everything by the book. We had a staging environment. We tested it on staging. It didn't happen there. Staging is much smaller in scale. We couldn't pay for like doubling the cost of production data just to have staging. We had object level versioning for every object in S3. So we did manage to restore it. It took about 100 million restore API calls to do.
Oh my God, they don't have batch restore.
No. And you know what? Just understanding what needs to be restored, right? Because you're on the thing.
Yeah.
Airflow is green. Like it looks like everything worked. We deleted more data than we had to, but which data actually got deleted? The only way to find out is to go through all the logs, try to figure out what was supposed to be deleted, what was not, restore them one by one, find all the cases where the bug occurred. It took us weeks. And it's a big reputation loss for SimilarWeb. It slew everything down. And no one wanted to touch retention after that, right? No one.
Now I have to ask you, how many new LakeFS users did you get after the multi-week, very famous Atlassian Jira downtime from several months ago, which resembles what you just described to a distressing degree?
Yeah, so Ido, who leads the customer success at Treeverse, loves the Atlassian story. It's so relatable. We've all almost been there. Some of us have been there. Yeah, I mean, if you have a system where you're afraid to touch production, you're afraid to modify the system,
you can't move.
You're by definition inhibiting innovation. Yeah. Right? No one wants to experiment. No one wants to improve anything. Migration to Spark 3.2, that looks interesting. I'm too scared to do it. I don't know how that's going to impact production. Right? Yes. So for us, just being able to kind of release ourselves from that fear, right? Being able to experiment, it's so basic.
Yeah. And you just touched on something that is so important and exactly on the line around all the fears that founders of companies have, which is cost, size of data, and retention.
Yeah, and that this is especially true on like S3 and like cloud services, because if I'm a data engineer, the only way to kind of get isolation is to create my own copy. Yeah. And then I use it, I forget that I used it, and then I never want to delete it.
Exactly.
It's too scary to delete.
And happened to me all the time.
Yeah. And then, I've seen this pretty much everywhere. No one wants to admit it, but it's always the case where you have like clickstream, like under the production paths. And then you have the same clickstream data under every home folder for every data scientist. And then again, like under temp or something like that. Yes. And this is production. Yeah. If you delete temp, the system is down.
So please tell me, how does LakeFS make it safe to delete data?
Okay, so before we do that, let's talk about retention. Okay, let's try to imagine retention, but on top of LakeFS.
Yeah.
So the first thing I would do before touching a line of code is to take my production data and branch off of that. I don't want to touch production, right? And again, in LakeFS, that's a metadata operation. I'm not actually creating a whole new like petabyte-sized data set.
Yeah.
I'm just creating another pointer to it, and I'm free to experiment and do whatever I want on that. So I would modify the code. I would run the modified code on my branch. And one of the nice things that Git allows you to do is to diff different commits, right? I can take the way the world looks after I modify the data and what it looked like before, and actually see which paths I'm deleting, right? How did my code affect the system? I can then take like my most important production ETLs and run those on that branch to make sure that they're not broken, right? Whatever downstream dependency I have, I can actually validate that it still works on that branch.
So you managed to fake delete essentially? So it looks to me like my data is deleted, while it's actually not deleted, but also not copied.
Exactly. So imagine just writing a tombstone, if I'm going to use a like database language for a second.
Like it's like
whoever,
it's delete, but because you did, but you're saving by not creating a copy, and then at some point you actually delete, which is exactly what I would want to do. For you, it's built in.
Exactly.
And do you let me do things like, let's say I fake deleted. I would like to deploy a fake delete, and then maybe, let's say, certain days later when GDPR kicks in, actually delete. Is that something you kind of...
Exactly that.
I didn't even practice for this question, I swear.
That's true. Yeah. So in LakeFS, we have something called garbage collection, which does exactly what the name suggests. So you can define garbage collection rules, right? You can say, on my main branch, I want to be able to go back 2 weeks in history, but no more than that. So if I deleted something 15 days ago, it would actually physically get deleted by that 2-week mark, right? For GDPR, that's typically kind of the time frame we're talking about. So this gives you kind of the benefit of both worlds, right? If I do retention and there's an issue there, I can always revert back to the way the system looked like before I introduced the change, right? I'm safe on that regard. But if I have to physically delete something, I get now this window, which everything past the window then gets deleted.
So I think I kind of see how what LakeFS would do if I bring it into my engineering team. Is there any case where you're like, Gwen, don't adopt it yet, wait, like you're not the core use case at this point, it's not going to be a good fit for you? Because
operating LakeFS, using it in scale, so we've tested it, and we have users who are actually using this on very, very large data lakes. I'm talking tens of petabytes, sometimes even more, billions of objects. So scale would probably not be your limitation unless you're, I don't know, Google or Facebook or something.
What if I don't have a data lake? What if I want to apply to production data? Is that...
So one of the limitations for the system nowadays is that data needs to live on an object store.
Oh,
it has to be S3, Azure Blob Store, Google Cloud Storage, Min.io if you're on-prem.
So all the integration I saw, it's not where the data lives, it's where the data comes from and how I get it there. That is...
Yeah, so we have different integrations, right? One's for like input, like Kafka Connect is a kind of an input for LakeFS. And then we have like native readers and writers, like Spark both reads and writes from LakeFS, and we have a native driver for that. If your data is not in an object store, we currently just don't support it yet. Part of our vision is to be able to support data wherever it is. And the nice thing that's happening, if you talk about like the state of data engineering, is that while we kind of support more and more things going forward, right? LakeFS expands its integrations. The opposite is also happening. So we see a lot more tools now supporting S3 as a storage layer, object storage layer. I mean, Snowflake, as of 2 months ago, officially support Iceberg on S3 as kind of a first-class citizen. You can read and write. You can do multi-table transactions on S3.
Amazing.
Yeah, like we had on our roadmap to support Snowflake. It's pretty much the most common request. And now they made it so much easier for us.
Amazing. And yeah, that speaks a lot to the kind of architecture you're advocating, the fact that it's just being picked up by slightly more mainstream players. I mean, not that data lake is not mainstream, but I do feel like data warehouses are still a bit more towards it. So when are you adding Postgres support?
Ooh, that's a good question. Maybe the opposite question is, when would Postgres support S3 as its storage backend?
This is exactly what's going to happen.
Yeah. In the meantime, I can recommend Dolt.
Okay.
Exactly that. It's from a company called Dolt Hub, I believe.
Okay.
And it's essentially Git for data, but for relational databases. I don't remember if it's like supports like the Postgres protocol or the MySQL protocol. I think it's MySQL. But that's kind of their niche. That's what they're aiming for. More like operational data, less analytics, but more like operational data.
Okay. Next
Yeah,
thing.
it's a very interesting project.
Next thing to do is to get them here.
Absolutely.
So with I think you kind of touched on that, but I want to make it extra clear to all the listeners. Suppose that the world, you wave the magic wand, we all have Git for data on all our data sources because we managed to do it in every single data store in the world, or everyone migrated to S3. How do you see the world being different than it is today?
That's a great question. So I'll stick with the analogy with Git for a second. So Git kind of, it's not a very opinionated tool in its own, but it kind of lends to specific workflows, right? So like Git flow, stuff like that, that's very common nowadays. So if you like switch jobs as a software engineer, you kind of know what to expect, right? The names might be slightly different, but the concept is kind of the same. There's like some sort of main branch. There's a concept of a PR, sometimes with different names, tests that run, different environments where you can tag and release to. Ideally, we want to kind of bring that concept to data as well, right? So if I'm a data engineer, I know that I have Git for data there, and wherever it is that I'm working, when I talk to an analyst, I can tell them, look at the events table for V0.1, for V5.2. We can actually collaborate by speaking the same language, right? It could be data scientists, data engineers, analysts, whoever it is that's consuming the data. We now agree on the same truth, essentially, which is really hard to do.
Yeah, no, I agree. I can just imagine having a conversation with someone in finance and he says, hey, I'm thinking there's something weird with the numbers. And I say, well, what version are you on?
Exactly. And like, it's notorious for data engineers that the world just changes underneath their feet, right? So if I have a bug on my iPhone, like one of the apps break or something, and I open a support case for whoever's developing that application, the first question they're going to ask me is, which version are you running? Right? They want to be able to reproduce it. You can't get reproducibility without talking about the same version.
Yeah, and the number of times I've had difficult conversations around whether a certain deal should count in that quarter or not. And if I could just have two branches, one with this deal, one without, someone else figure out what you want to do next, I'm out of here. My life would have been so much easier. But with some conversations, why does the data engineer need to be part of this discussion in the first place, right?
Exactly. And it's always, it gets worse when you have like backfills of data, right? So I showed a dashboard yesterday, but yesterday's data changed today again because I got new information about yesterday. So now I actually have two versions of the data. I have the data that I made the decisions based on, right, which I had yesterday. And then I also have yesterday's data, but based on what I know today, which is essentially another version of the data.
Yeah. And I'm seeing like something, the shift left push is obviously toward empowering engineers. And you already mentioned that you empower engineers by making them less scared to make mistakes by having versions, as they should have. But I think when you say Git for anything, I'm also thinking forks. And I'm thinking about the fact that a fork could become eventually the new source of reality if it's getting proven to be more useful than in different ways than the old other source of evolution. So I can imagine that if I'm a data analyst and I think all my colleagues are idiots and I have a PhD from Harvard and they don't, and I want to prove out a thesis around how the new data analysis is a better reflection of reality and more useful to the business, I can now do it without getting into a fight with anyone.
Exactly that.
Leave out
And more so,
idiots and we're good.
and like even answering the most basic question. Let's say that you don't use LakeFS and you do end up actually copying the data to get that isolation, right? You fork by actually copying the entire data set. And if you're a good data engineer or data scientist, you're probably not going to use the data exactly as is. You're going to massage it a bit. You're going to enrich it. You're going to use it with some other additional tools. And then just being able to answer the most basic question, which is what actually changed, right? Yeah, it's better data, but how is it different?
Yeah.
What changed?
Yeah.
And for that, you need version.
And but also explaining why it changed, because you can now manage. Actually, I'm guessing it's true. I don't know if it's true, but it sounds like I can actually manage my code changes and my data changes in a coordinated way.
Yes.
So I can say, this is a change in the data, and it changed because this is the type of assumptions that I now have baked into my analytics.
Yeah, and this is actually something we see a lot with data science use cases, right? So with data science, or like science in general, you have experiments, right? And you want experiment, by definition, a scientific experiment needs to be reproducible.
Yes.
Right? I want to be able to go back to that thing that I ran a week ago and get back the same result.
Yes.
As long as my code is deterministic, this should work.
Yes.
The problem is your data lake, which is, again, a fancy name for a huge shared folder that everyone reads and writes from, right? You don't get that guarantee for your input data. For the code, you have it in Git, right? I can refer to the same notebook, to the same pipeline that I ran a week ago. But if I run it on today's data, someone already did a backfill. They modified it. They changed it. They dropped a column. They did stuff. Can I run it again and get back the same result?
Yeah.
Right. This is
and
so
this
hard
also
to
brings quality engineering into
Yeah.
data world. Absolutely.
Exactly. So one of the things LakeFS lets you do is actually, when you create a commit in LakeFS, you can attach like arbitrary key value pairs to it. It's kind of additional metadata that you want to capture. And I think the most common ones we see is like a link to like a GitHub commit, right? To a commit of like your notebook or your ETL pipeline that generated this data.
Yeah.
So you can always refer back to both.
Yeah. And I love so many things here because it ties into reproducibility, which is another huge thing. It ties into something that's just been a theme for me personally through my career. Like the reason I love Kafka is it allows you to kind of consume your own data and do the things you want. Yeah. This can obviously get copies of data get expensive. You're letting people do it without a copy of the data. Exactly. So this is, and I've seen firsthand how much being able to get your own copy of the data empowers teams. Having it managed as a Git is such a huge deal.
Yeah.
Wow. Last question, because I'm keeping you over time and I'm a bit sorry about that. I know it's late for you.
So happy to talk to you.
You have this really wide experience. First, building this we used to call them data-intensive applications. I think now the trendy term is data products. And now you are building tools for the people who are building those things. Let's say that I'm CTO of a startup that wants to build data-intensive application. What some advice? What is the one thing I should absolutely keep in mind and make sure I never forget?
So this is very much biased to my background, again, from system engineering. But I believe it really, really helps, maybe for data engineers more than software engineers even. And that would be to have a very, very deep understanding of the tools that you're using, right? So like my rule of thumb is to know at least like 2 abstraction layers below from what you're working on. You should be able to know them very well. Don't manage them. It doesn't mean like, okay, I'm using Kafka, I should definitely run my own clusters and roll it myself in Kubernetes. You probably don't want to do that. That's not your core business. But you should definitely know how they work, which trade-offs they have, how they actually deal with like your use case. You really need a good understanding of those tools. Just the fact that you get them as managed services doesn't like alleviate you from the need to actually understand them. I think that would be my biggest advice.
Yes. Yeah. And I have to add that literally every time I got bitten by surprising property of a system, it was always because, after the incident settled down and we could figure out what happened, we managed to find the one line in documentation somewhere that said that what happened to us should have been 100% predictable. So basically, read the docs, all of them, even the
Read the
small
docs. Yeah, and tying back, right? Experiment, try it out, read the
Yes.
code, right? So much of this is open source nowadays. Don't be afraid to kind of get dirty and like look at the bits and bytes and actually understand how things work.
Absolutely. Thank you so much, Oz, for this the conversation. I learned a lot and was also quite inspired. You have an inspiring vision for the world.
Thank you so much. It was my pleasure. Absolutely. Always love talking to you.